Hello student, welcome all of you on our YouTube channel, that is Department of Mathematics, Sanjeevanee Mahavidyalaya Chapoli. This is lecture for the third year student, BA B.Sc third year student. Paper is linear algebra, semester 5th, and our lecture is 18th. Today we are going to discuss very important lemma, and statement is already written. What is that? This statement is that if nu1, nu2 to nu_n belongs to the V are linearly independent vectors. So this nu1, nu2, nu_n are linearly independent. We know the definition of linearly independent vectors. Then every element in their linear span has a unique representation in the form. Then the element of the V can be represented, or all these elements can be represented in unique form, and that unique form is lambda 1 nu_n, lambda 2 nu2 to lambda n nu_n. With this lambda I is the constant, and this constant belongs to the field F. But this representation is the unique. This representation is unique. No other chance to write their linear combination in the other form. Now we have to show that this representation is unique. Now let us start our proof. We know that by the definition, every element in linear span, every element by definition of the linear span, so every element in linear span can be represented as lambda 1 nu1, lambda 2 nu2 to up to dash lambda n nu_n. This is the representation of the linear span. Now we have to show that uniqueness. So we must demonstrate that. So we have to show that this is a unique representation. We consider here one contradiction, that is, we can represent this element in other form. That means we have to demonstrate lambda 1 nu_n, lambda 2 nu2 to up to dash lambda n nu_n is equal to mu1 nu1 to mu_n nu_n. That means if this representation can be expressed in this way, this expression can be represented in this way, that means we are going to contradict assumption. Our assumption is contradiction assumption. Suppose this expression can also be written in the other form, and that other form is this mu1 nu1 mu2 nu2 to mu_n nu_n. Then, so if the representation is unique, then it must be necessary lambda 1 is equal to nu1, lambda 2 is equal to mu2 to lambda n is equal to mu_n. Any doubt? Now we call this is equation number first, and from the equation first we can write from this equation lambda 1 minus mu1 into nu1 plus lambda 2 minus mu2 into nu2 and so on lambda n minus nu n is equal to 0. So which by the linear independence of? So which by the linear independence of these vectors? So these are linearly independent vector. We have to given that in statement. What is that? What is given? Nu1, nu2 to nu1 belongs to we are the linearly independent. So if all these are linearly independent, then these all coefficient must be 0. So lambda 1 minus mu1 is equal to lambda 2 minus mu2 is equal to 2, lambda n minus mu n is equal to 0. All these must be 0. So from this and from this we conclude that lambda 1 is mu1, lambda 2 is mu2 and lambda n is equal to mu n. Isn't it? So all these are equal. So for all lambda I is equal to mu I. That means we was considered that this representation is equal to this representation, but we observed that we found that all lambda 1 mu1, lambda 2, mu2, all lambda and mu's are equal. So that means this representation is nothing distinct, is not distinct from this, and therefore this representation is unique representation. So this lemma is over. You revise it. In next lecture we will discuss one theorem. So today we stop it here. Thank you.